This is question 48 on chemistry from the 2020 IMAT. So we're given a list of 5 different molecules and we're asked which of them has a permanent overall dipole moment. We're also told the group in the periodic table of all the elements concerned. So what information is generally useful when we're determining whether a molecule has a dipole moment? So it would be handy if we could visualize the shapes of each of these molecules. And what concept can we use to determine that? So that is called valence shell electron pair repulsion theory. And that basically says that the bonding pairs of electrons and the lone pairs of electrons will maximize the distance between each other, and that allows us to predict the shape of each of these molecules based on the number of bonds and the number of lone pairs. So let's firstly apply that logic to this NF3. So firstly, nitrogen, we're told, is in group 5. What does that mean? So it has 5 outer shell electrons, and fluorine is in group 7. And so that has 7 outer shell electrons, and so will only form 1 bond to complete its octet. And so we can see that nitrogen is going to be surrounded by 3 fluorine atoms. And where will these be in space? So it would have used 3 of its 5 outer shell electrons, leaving 2 behind. And these 2 will form a lone pair. And so what that looks like is something like this. So we have this trigonal arrangement, which results from the fact that this lone pair and the 3 pairs of electrons in covalent bonds will together form a tetrahedron, and because that is the shape that maximizes the angle and distance between them all. But because the lone pair doesn't count as part of the overall shape, we call this a trigonal pyramid. So do we think this has an overall dipole moment? Well, let's think about the dipole across each of the 3 bonds. So fluorine, we know, is the most electronegative element, and so all 3 of these bonds will be polarized towards fluorine. So the electron pairs are closer to fluorine than they are to nitrogen. And what does that mean for the overall dipole? So there will be a net overall dipole moment pointing towards the fluorine side of the molecule. And so we know that NF3 definitely has an overall permanent dipole moment because we've used our theory to predict the shape, and this shows that there will be a net overall dipole moment towards the side that has fluorine on it. So let's have a quick look through the rest of our molecules and see why they do not have an overall dipole moment. So what about PCl5? Well, phosphorus is in the same group as nitrogen, so it again has 5 outer shell electrons. Chlorine is a halogen, again with 7 unpaired electrons, so chlorine will form only 1 bond. So we have a central phosphorus surrounded by 5 chlorines. And what shape would this take? Well, phosphorus is using all 5 of its outer shell electrons. It's allowed to do that because it's a second row main group element, and so its larger size means it can break the octet rule because we have 10 electrons around it if we have these 5 bonds. And what shape does a 5-membered molecule look like? So this forms a trigonal bipyramid, like so. This is the arrangement that maximizes the separation between all of the chlorines. So what are the dipoles doing in this molecule? Well, chlorine is slightly more electronegative than phosphorus, so all of the bonds will be polarized towards chlorine. But does this mean there's an overall dipole moment? Well, let's think about whether these will cancel out. We can see we have these 2 axial chlorines pointing in different directions, or opposite directions, so these will cancel out. Then we have these 3 equatorial chlorines in a triangle, and the 3 of these together will cancel each other out. So there is no overall dipole moment because of the symmetry of this molecule. Now, what about SF6? So again, we're going to have a central sulfur surrounded by 6 fluorines because fluorine forms only 1 bond. Sulfur is in group 6, so it has 6 outer shell electrons, and so it will form 6 bonds with no lone pairs to the surrounding fluorines. What would that look like? So we know molecules with 6 atoms around a central atom form an octahedron. So this maximizes the separation between all the fluorines. And sulfur, again, is in the second row of the main group of the periodic table. And so its bigger size means that it is allowed to break the octet rule. And so what are the dipoles doing in this molecule? So we know fluorine is the most electronegative element, and so all of these bonds will be polarized towards fluorine. But because of the high symmetry of this shape, all of these pairs of opposite dipoles will cancel each other out. So there is no net dipole moment in SF6. How about CCl4? Well, we know carbon is in group 4, so it has 4 outer shell electrons, meaning it forms 4 bonds to chlorine with no lone pairs, and the resulting shape is this tetrahedron. The bonds will be polarized towards chlorine because of the relative electronegativities. And does this mean there's an overall dipole moment? Well, no, because again we have a high symmetry arrangement, and all of these dipoles in the bonds will cancel each other out overall. So we know CCl4 does not. Then finally, what about carbon dioxide? So we know carbon forms double bonds to oxygen, and so it'll use 2 of its electrons in one double bond and the other 2 in the other. And so if there are 2 bonds and no lone pairs, what shape results? We have this linear arrangement to maximize the separation of the oxygens. So what happens to the dipoles? Both of the bonds are polarized towards oxygen, but because they point in opposite directions, they overall cancel each other out. So we've seen why NF3 is the only molecule to have an overall dipole moment. That is because it is the only one without a high symmetry structure where there is a net cancellation of dipoles. So our final answer is NF3, which corresponds to A.